Hey guys, in this video we are going to learn how to factor using GCFs and how to factor trinomials when a is equal to 1. So at the top of page 18 in your notebook, it starts off by talking about what factors are. Now it's important to know that factors are numbers that divide into another number equally. So what that means is if I take a number, for example, 18, I'm trying to figure out what numbers go into 18 with no remainder. So obviously 1 goes into every single number. And 1 times 18 is 18. So 1 and 18 are both factors of 18. Similarly, 2 and 9 are factors of 18. 3 goes into 18 times 6. And after that, there's nothing because 4 doesn't go into 18 and neither does 5. All right, now let's try 36. So we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6, because 5 doesn't go into 36. Now, if you're looking here, I kind of skipped over the directions for this section. It says find the GCF of 18 and 36. So GCF stands for greatest common factor. So greatest just means biggest, common means they both have it, and a factor is something that divides into that number. So I'm looking for the biggest number that divides into both 18 and 36. So if I'm looking here, 18 is in both of 18 is the factor of both 18 and 36. So that means the GCF of 18 and 36 is 18. And it's important to know how to do these kinds of things because when we get to factoring using GCFs, this is what we would be doing. All right, so let's practice this a little bit more down here in the section in the middle of the page. So it says, find the greatest common factor of each pair of numbers. So we have 12 and 60. Now you could list off all of the factors of each of these numbers, but typically what I like to do is find all the factors of the smaller one and then take my calculator and start dividing and see what is the biggest one that goes into the other number. So 12 is the smaller of the two numbers, so I'm going to find all the factors of 12. So we have 1 and 12, 2 and 6, 3 and 4. And you know that you have all the factors when either the factors are consecutive, like 3 and 4, or they are the same, like the 6 and 6 that we had up here, or you keep going and you find out that there are no more numbers that go in between the two numbers that you got last. All right, so I have 1, 2, 3, 4, 6, and 12. So what I'm going to do is I'm going to take my calculator and I'm going to start dividing 60 by each of these numbers. Now, you don't necessarily have to use your calculator. You could do this using facts that you already know, but I'm going to show you how to do it just in case you don't know all these facts. So I'm going to do 60 divided by 12 because that's the biggest factor of 12, and I get 5. So right off the bat, my GCF is 12. All right, let's try number 2. 14 has a few factors. It has 1 and 14 and 2 and 7. There are no other factors of 14. Now, when you are doing this, guys, I do recommend that you go in order. So I would have done 14 divided by 1 and got 14. So I know 1 and 14 go together. 14 divided by 2 is 7. And then I would have done 14 divided by 3 to find that I get a decimal. So I don't want to keep that. 14 divided by 4, 5, and 6 are all decimals. So I wouldn't write any of those. That's how I know that I have all the factors. Now let's take 49 and divide by 14. We get a decimal. So I don't want to keep that. 49 divided by 7 is 7, so that means the GCF is 7. All right, we'll do one more together, and I'll save the last 3 for you to do on your own. All right, so we have 55 and 21. So I have 1 and 55. 55 is not divisible by 2. It's not even. It's not divisible by 3 or 4, but it is divisible by 5, so it's 5 and 11. 55 is not divisible by 6 or 7. I'm just checking to make sure. 8, I don't think there are any more factors of 55. 9 doesn't work, and 10 definitely doesn't work because 55 does not have a 0 at the end. All right, so let's take a look at 121. So 121 divided by 55 does not work. But I do know that 121 divided by 11 works. So 11 is my GCF. All right, so I'm going to leave the last 3 for you to try on your own. Now, if we go down to the bottom, sometimes you not only do you need to find the GCF of numbers, but you need to find the GCF of variables as well. So the example that we have is find the GCF of 27x squared y cubed z squared, 3x to the 4th y squared z, and 9x to the 3rd y. So this time we have 3 numbers that we have to find the GCF of. So let's start with that. First of all, 3 is the smallest number and it only has 2 factors. It's 1 and 3. 3 goes into 27 and it also goes into 9. So that means the GCF of the numbers is 3. Now let's take a look at the letters. So it says the variable of the x factors, circle the smallest one. So what that means is I want you to find the x variable that has the smallest exponent, and that's going to be x squared. Now we're going to do the same thing with the y's. We have y cubed, y squared, and y. So we're going to keep the y. Now, if you're looking at the z's, notice that this last term here does not have a z. So we are not going to even keep the z's because all 3 of the terms have to have the same letters in order for it to be a part of the GCF, okay? So there's no z term here. So the GCF of this whole thing here, so the GCF is going to be 3x squared y. And if you look over here, it's 3x squared y. That is the GCF of those 3 terms that were given. All right, let's practice with a couple of these. So down at the bottom of page 18, we have 6x squared and 5x cubed. So we're going to start with the numbers. 5 is the smallest, so we have, let's find the factors of 5, 1 and 5. 5 does not go into 6, so that means the GCF of the numbers is 1. And then they both have an x, so I'm going to keep an x, and I'm going to keep the smallest exponent, which is 2. So the GCF is 1x squared. You don't have to write the 1, but it's not wrong if you do. All right, number 8. Let's find the factors of 15 this time. All right, so we have 1 and 15. 2 doesn't work. We have 3 and 5, and 4 does not work. 15 does not go into 20 evenly, and then 5 does, though, so we're going to keep the 5. So 5, they both have a y, and to the first is the smallest, so we're going to keep that first power. Now, you probably noticed that the 20 has a negative. Right now, we're not going to worry about it, but when we get to actually factoring, this would be important. If there's a negative in the terms that you have and it leads the polynomial, you will need to make your GCF negative, but for right now, we won't have to worry about that. All right, last one. We have the number 8. The factors are 1 and 8, 2 and 4. 8 goes into 16, so that's the number I'm going to keep. They both have q's, and squared is the smallest exponent, so I'm going to keep the squared. Now, at the top of page 19, you'll find more of these to practice, but I'm going to leave those for you to do on your own. All right, now, we are going to take what we just learned about finding GCFs of polynomials, and then we are going to factor them out, okay? So let's think back to something that we've done previously. We learned how to multiply polynomials, in this case, a binomial by a monomial. So what we would have done is we would have distributed like this. 6x times x is 6x squared, and 6x times 5 is 30x. Okay? So now you'll notice that we can find the GCF of these two things. Essentially, what we're doing is going backwards. So 6 and 30 have a common factor of 6. So I would take out a 6. They also both have an x, and the smallest exponent is 1, so that's what I would keep. Now, once you find the GCF, your job is to divide it out. Notice how that is the opposite of what we did here. We multiplied to get from here to here. So we're going to do the opposite, which is divide. If I divide both by 6x, you put your parenthesis. 6 divided by 6 is 1. X squared over x, remember the rule. Keep the base, subtract the exponents. 2 minus 1 is 1. 30 divided by 6 is 5, so I'm going to put plus 5, and the x's cancel because they're the same. Now notice how we get right back to where we started again. So factoring is just the opposite or the reverse of multiplying. It's important to know that for what we're about to do here. All right, so let's do some of these together, and then I'll leave some of them for you to do on your own. So take a look at number 13. We have 40x to the 5th and 24x to the third. 24 is the smaller number, so let's find the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 does not work. All right. 24 does not go into 40 evenly. I don't believe 12 does either, but 8 does. So we are going to take out an 8. Now they both have x's in common, and we're going to keep the smallest exponent, which is 3. So I put an 8x cubed out in front, and then a parenthesis. 40 divided by 8 is 5. X to the 5th over x to the 3rd is x to the 2nd. 24 divided by 8 is 3, so plus 3, and the x cubes cancel. And that would be your answer. All right, I'm going to leave number 14 for you to do. Let's take a look at 15. Now here is that negative in front that I talked about previously. First thing we're going to do is find all the factors of 35. So we have 1 and 35. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7, and then 6 does not work. All right, 35 does not go into 42, but 7 does. Now, notice that you have this negative in front here. Anytime your polynomial starts with a negative, your GCF must also be negative. Now, also notice that the 42 does not have an x with it, so you cannot take out an x either. So negative 7 is your GCF. Negative 35 divided by negative 7 is 5. The x stays the same. 42 divided by negative 7 is negative 6. Close your parentheses, and that's it. That would be your finished factor. Again, you cannot have a negative in front of in the very first term of the parentheses, so make sure you get rid of that. All right, let's take a look at number 17. 17 has 3 terms, the smallest of which is 10, so let's find the factors of 10. I'll leave some space and write it down here. So we have 1 and 10, 2 and 5. There are no other factors. 10 goes into 30, but 10 does not go into 12. Remember, you have to go into all 3 terms. 5 goes into 30, but not 12. But 2 goes into 30 and 12, so 2 is the number I would choose. My first term is positive, so my GCF is going to be positive. And then let's take a look at the letters. They all have an x, so I keep an x, and the smallest exponent is 5, so it's x to the 5th. They also all have a y, so I'm going to keep a y. And 6 is the smallest exponent, so it's going to be y to the 6th. So that means my GCF is 2x to the 5th, y to the 6th. Open a parenthesis. 30 divided by 2 is 15. X to the 7th over x to the 5th is x to the 2nd. Y10 over y6 is y4. 10 divided by 2 is 5. X13 over x5 is x to the 8th. 8, 9, 10, 11, 12, 13. Yep. Y12 or y6 is y6. I'm going to run out of space. My apologies. Negative 12 divided by 2 is negative 6. And then if you look, each of these cancel because they are the same. If you do it correctly, guys, when you find your GCF of the letters, one x should cancel somewhere and one y should cancel somewhere. All right. I think I'm going to leave the rest of these for, actually, no, let's do number 19, and then I'll leave the rest for you to try. Now, even though it's not there, remember there's an invisible 1 in front. 1 only has one factor. It's 1. So the GCF is 1. They both have an x, and to the first is the smallest exponent. So that's what I'm going to keep. 1x. 9 divided by 1 is 9. X squared over x is just x. 1 divided by 1 is 1, and the x's cancel. So that would be your finished factor. Now I'll leave the rest for you to try. Okay. All right, so we are going to talk about factoring trinomials when a is 1 next.